So what is the potential of IoT and 5G? Well, if you don't think that 5G can anchor new business cases, let me stop you right there, because when we look from a mobile operator's perspective at IoT, it looks pretty impressive. So we've taken the chance to look at the life of a car, the whole life cycle of a car. And if you can anchor into all of these kind of cases where the car is connected throughout its life cycle, then you have lots of business there. And when we talk about life cycles, we have to start with the birth. Here is a car factory. A typical car factory today resides on something we call Industry 3.0. Let's say you have 10,000 square meters, and inside there is about 1,000 robots, all individually connected with their own brain, their own PLC. So you got a very efficient factory, but you don't have a flexible factory. You can't change what you produce very quickly, for instance. Industry 4.0, or smart manufacturing, is where we bring in our power. 5G can deliver as good and as reliable as a cable. So if we can remove all the cables, we don't have 1,000 points to reprogram. We have 1 point, one brain, and that will change the whole factory floor and what you produce. You also have automatic guided vehicles today, often going on a rail that needs to be reprogrammed. Well, 5G delivers precise positioning down to centimeter level as well. So here you can see the factory as it is, but also digitally copied up into a sort of cloud environment. And that's where you can bring in supply, you can bring in research and development, manufacturing, and transportation into one homogeneous layer, if you will. So smart manufacturing will exist, but it also will need 5G. The module inside the car that will later be used by the driver is here used to make the car. And as it's transported out of the factory, then we transfer that module into more of a transportation or logistics module. And that is the next step in life of a car. So now the car is transported out of the factory, and we switch the module over to be used for more a logistical purpose and into a port. Now, remember, about 90% of all things we produce are shipped through ports. So these are really an important customer for you. And it pushes the need for the network to be really, really tough here. That's why we see the private networks coming into hand here. In a port like this, many things are automated, and for instance, automatic guided vehicles are there. We can see the need of a traffic tower, even though it's very much automated, because if you have these automatic guided vehicles or autonomous vehicles and there is something strange that happens, in this case birds is in front of it, it will completely stop. And it will be very unnecessary to go down there and fix the problem, instead using the traffic tower and remotely connect to a vehicle. But if you're remotely connected to a vehicle, it better be very reliable and very fast, especially if it's among other people. So, shipping the car is the next step. The module is switched over to be used for logistics purpose. Next step is to activate the car, and that's over here. So here is where we activate the car. Now you need a global offering, for this is happening all over the world. Cars are sent anywhere and everywhere. It's very similar to the water pumps of Grundfos actually. They are sent all over the world and continuously extracted information from by the water companies. So activation might mean activation of software that it needs to be upgraded to the car using that same module, but also different services that are wanted by the one who buys the car, Spotify and other entertainment services. Next step is see the car in action, and that's over here. Now, I just want to mention a little bit about autonomous vehicles and autonomous driving in specifics, because that's a 5-step ladder. Where step 1 is things like cruise control and parking assist. Step 2 is hands-off, and we do have those kind of cars today. But when we move into step 3, which is actually eyes-off, and step 4, mind-off, you can take your little nap in the car, or step 5, which is steering wheel is optional. Well, then we need not only the cars to be very smart, but the surrounding to become very smart. We need cars to be able to talk to other cars. And in 5G we call that side link, or vehicle to vehicle. We need cars to look around the corners, and radio can do that, so cars can be warned that there is a danger ahead. We need a traffic cloud kind of situation where cars teach other cars that the ground is actually dangerous in front of me. So that kind of environment, we foresee 5G can deliver a lot. Now, if you imagine also going a bit rural here, there is about 200,000 kilometers of road in Sweden which is not covered today. So if the car is aware of the network quality ahead and it knows where you're going, it can, for instance, download quickly where it has good connection, a movie, and then you can enjoy that on those rural roads. Or it can suggest an alternative route if you still want to be connected continuously throughout your trip. You can also see that features can be altered in vehicles. For instance, slippery ground might be higher suspension in the car, or hilly areas you might want to have more horsepower. But in flat ground, you don't want those horsepower because they consume too much diesel, for instance. Now, let's move in to the end of the car. So now we're talking about end of life. And recycling of all materials in the car can be done much more efficient if you know the history of the car. You need to recycle the materials, but not only the materials, also the IT components need to be recycled and decommissioned, or possibly recommissioned, depending on their status. So what I'm saying here is that we can have a much more efficient recycling process if we know the history of the car. Now let's bury this car, may it rest in recycled pieces.